Okay, we're going over properties of logarithms, and we're going to start with the change of base. You're required to do one of the problems in writing a logarithm as a quotient, and this is what they mean. So common log of A over common log of B is one way to write it. That's using the LOG button. We can also write it as a natural logarithm. Same idea. Remember, the order you do this in is the same as the order these are given in. The one that's a little bit higher goes in the numerator, the one that's lower goes in the denominator. Okay, let's go over the product rule. Now, one thing to notice is that these are the two logs of the same base. We're just calling it base B. If we're doing addition outside of logs, we can simplify this to log base B, and those two things get multiplied inside a single logarithm. So one direction we're compressing, the other direction we're expanding, and we will be using these extensively in the quiz. Okay, quotient rule. The way this works is if you see a negative logarithm, it always goes in the denominator. That first logarithm is positive, so we're going to write this as a single logarithm because they're both the same base, and it's A divided by C. If both of these logs were negative, we would write this, and I'm going to write this and erase it because I want to emphasize that it has to do with which logarithm's negative, not which one's first or second. But if they're both negative, we would write this as log base B of 1 divided by A times C. Okay? So if it's a negative log, it always goes in the denominator. If it's a positive, it goes in the numerator. Okay. So go back to the original question. Okay, power rule. And this has to do with if we have it doesn't matter the log base, if we have something inside the log that has an exponent, we can rewrite it by taking the exponent on the outside and just turning it into a multiplier. Okay? So those are the rules we're going to use in expanding or contracting. Example 1 is just to use the change of base form. And notice that they're asking you to write it as a natural logarithm. So we're going to write ln of 9 divided by ln of 4. And I do believe they want you to use those parentheses in XYZ. It gave me an error when I did it. Okay, we're going to practice using the compression and expansion rules, the division and the multiplication for addition subtraction. And look, on these, they want you to even factor the numbers. So let's think of this as log 2 times 5, not 2.5, 2 times 5 times x, okay? And the reason I'm spelling it out this way is because you are expected to write this as log of 2 plus log of 5 plus log of x. So you can't just write the 10. You have to factor out everything. Now, fortunately, the numbers they give you don't have a whole lot of factors. Okay, I found this kind of problem, part B, confusing until I figured out that here's what they wanted us to do. They want us to write that as an exponent, log of 5 squared. And then we're going to move that exponent to a multiplier, 2 times log of 5. Okay? And I should probably identify my answers here. All right, so on C, we have division, which we turn into subtraction. So let's just start by writing log of 2 minus log of x to the third, and it is expected that you change those exponents to multipliers. So the final answer is going to be log of 2 minus 3 log x. All right, they get more complicated. So we've got two things that are multiplied in the numerator and then a division in the denominator. So let's just break everything out. Log x to the third plus log y to the fifth minus log z to the fourth, and they're going to expect us to turn those exponents into multipliers. So the final answer is going to be 4 log x plus 5 log y minus 4 log z. Okay. With E, it turns out, and this is a lot like the problem you'll see in XYZ, we can actually factor the numerator. I can do a monomial factor. I can pull a 4x out of both terms. 4x times x minus 2. And 4x, x plus 1, x minus 3. I think this is worth doing because we can reduce a little piece of that. And I have not given us enough room. It turns out, though, on the quiz, it doesn't matter. It doesn't care if you reduce it or not. I just like to type less. So this is going to turn into log of x minus 2 minus log of x plus 1 minus log of x minus 3. Again, everything that's in the denominator is a negative log. And we're done with that. Okay, let's take a look at F. Do an F because what you have to remember is how to turn a radical into a rational exponent. And remember, it's power over root, okay, just like a tree, okay, at least the root part. So, I completely forgot to include a log here. So let's throw that in. So y, power over root, and now we're going to turn that into a multiplier. 5/3 log of 1. All right, let's do the same thing here, same mistake, log, big old parentheses, and this is going to be kind of challenging. Okay, I'm going to rewrite the radical as a rational exponent, and I'm writing in the 2 that gets implied on a square root. So this is going to be log x plus 1 x minus 3 squared, all to the 1/2 power. Okay, and let me get big parentheses here, over x squared minus 4. Now, x squared minus 4 will factor to x plus 2, x minus 2, but it won't reduce anything, so I'm just going to leave it like it is. And now I'm going to simplify my exponents. So the 2 and the negative and the 1/2, they cancel. It does leave me with a 1/2 in front of that first binomial. So log x plus 1 to the 1/2 power plus x minus 3, log x minus 3 minus log x squared minus 4. Now, I can't turn the exponent on that x squared into a multiplier because I can't detach it from the minus 4. But give myself a little more space here. And we'll finish it up. So we get 1/2 log x plus 1 plus log x minus 3 minus log x squared minus 4. Okay, that video went a little too long. I'm going to stop it, and I'll see you in the next one.